In this video, we're going to talk about two important normal forms of context-free grammar. So just remember, context-free grammars, the left-hand side has a single variable and the right-hand side has no restrictions. But there are two normal forms, and these are important normal forms, so we're going to learn about these and how to convert a context-free grammar into one of these two normal forms. So the first one is the Chomsky normal form. All productions in the Chomsky normal form have, of course, one variable on the left-hand side, but on the right-hand side, you can have no more than two variables, or you have a single terminal symbol. So you have to, all of the productions have to either have one or two variables on the right-hand side or a single terminal symbol on the right-hand side. Greibach normal forms, all the productions are in the form of one single terminal symbol followed by any number of variables. So let's take a look at this in more detail. So here is a Chomsky normal form. So we can take a context-free grammar, go through a few steps, and convert the grammar from just a context-free grammar to the Chomsky normal form. So let's go through the steps to do that. So if we take a look at this, what are the rules on this? It means that each production, so this one is not okay, this production's not okay, and this production's not okay. So on the right-hand side, you can have two variables, or you can have one single terminal symbol. So the first thing we want to do is we want to introduce three new variables, and each of those three new variables will end in a terminal symbol, right? And we can replace them, substitute them for the variables. So we would start by your book uses the variable b. It doesn't really matter. You can use any letter. The variables are just letters. Like you can start with S, but you don't have to start with an S. You could use A, you can use X, but I'm going to stick with what the book did. So the book introduces three new variables: a B for the terminal symbol A variable B for the terminal symbol B, and a variable B for the terminal symbol C. So what does that mean? We have three new productions. We have a production BA, which is in Chomsky normal form. We have a production BB, and we have a production BC. That's sub. Again, this is a single variable, just the single variable name is B sub A, B sub B. I just didn't want to have to say that. Then you can replace here, so we go here, and we still have A and B. Those are separate variables, but in place of this A here, we're going to put our new variable BA. Now this is still not in Chomsky normal form because it has three variables, so we're going to have to do another step in order to do that. All right, so then our next one, our A, is going to be replaced by BA, BA, and BB. Again, we're going to have to take another step from here, but for right now, we can keep this, one step at a time. So the third one here is going to be A and then BC. So if you take a look at our grammar right now, you can see that this one is this one's fine, this one's fine, this one's fine, and this one's fine. But we still have to deal with these two grammars right here because you can't have three variables on the right. You can only have at most two variables on the right. So the next step we're going to do is we're going to take these two variables and replace it with a new variable. So we can introduce, I'll follow with the book, they introduce D1. And then we can take these two variables here and replace it with another variable. So we'll introduce D2. So now we have these two new productions where we have D1 production is B sub A, and D2 production is B sub A, B sub B. So again, the names D, B, A are not really, doesn't really matter what name you give the variable. You just need to make sure that you have a single variable on the left and no more than 2 variables on the right. So then we can use substitution here. So we have S, we keep the A, but then we have D1. So then D1 is going to go to BBA. And then also for our production with the A, we keep BA, but then we have D sub 2. So I know it's hard to kind of see because my handwriting, but in the next slide I have it all nice and neat for you to look at. And then these productions are still in Chomsky normal form. This is a B sub C, then B sub A, terminal symbol A, B sub B, terminal symbol B, and B sub C, terminal symbol C. All right, so in this, you can only have no more than 2 variables, but you cannot have unit productions. So actually, it must have 2 variables on the right-hand side or a single terminal symbol. And you can have no lambda productions. Here we are. This is the same thing I just did. It's just much easier to look at, all nice and neat. We started out with this, which is not in Chomsky normal form. So first we wanted to make single terminal symbols. So we introduced these 3 new variables so we could make 3 productions of this type. But then we noticed that we still have some productions that are, that have 3 variables on the right. So we introduced 2 new ones to replace this one and to replace this one. So we have D1 is that one, and D2 for that one. And so now we can, this is now in Chomsky normal form. I'm just going to erase this so you can see it. And this is also in the notes and the slides. All right, so there's a second normal form called Greibach normal form. And in this one, all the productions must be in the form of a single variable. Okay, of course, a single variable on the left-hand side. On the right-hand side, you all must be in the form of a terminal symbol followed by any number of variables. But it must be one terminal symbol followed by any number of variables. So right here, you can see that this one is fine and this one is fine, but this is not in Greibach normal form. So you can use substitution in order to do that, in order to handle that. So this production is fine. This is Greibach normal form. This one is as well, and this one is as well. And this is a single variable, so this one also is fine, but this one is not. So we can substitute the A here with a B. So we just took this A that is here and we substitute it with here. And also you have to use all of them, so we can substitute here with B, 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 or the third one with B, B. So now we do have this is all of the production in Greibach normal form. All right, so here's another example. In this one, this is not in Greibach normal form. Neither of the productions are in Greibach normal form because this has 2 terminal symbols and this has 2 terminal symbols and a variable and a terminal symbol. So in order to convert this, you can introduce some new variables. So if we introduce a new variable A for our terminal symbol A and a new variable B for our terminal symbol B, and then you substitute. So let's start here. with this is our grammar, A, B, S, B, and we have this one, and neither of these are in Greibach normal form. So we will create a new one that is A, and another one for the B. And then here we can substitute in for B, and here we could substitute in with the A. So our new productions for this would be, we were going to keep this A, but then we have a B here for the B substitution. We keep the S, and we have a B here for the B again, because this is not in the right normal form. And then for this one right here, we just substitute, we keep our first terminal symbol A, but then we add a variable here. So now we have our grammar is in the Greibach normal form. So this is just saying that any context-free grammar that does not have the empty string has an equivalent grammar in Chomsky normal form and also has an equivalent grammar in Greibach normal form. Obviously, if it's the empty string, that has to have a lambda production, so that would not, there's nothing you can do about that when you are doing these normal forms. Later, we will get into closure properties of context-free languages. But before we do that, we are going to, the next module, we are going to get to non-deterministic push-down automata, or the automata for context-free languages, and then the closure properties of context-free languages.